Hello students, this is Mr. Maat with another physics lesson. In this lesson we will only focus on the relationship between different quantities. Well, that's the thing that we study with physics. We always want to know what happens with one quantity if I double the other quantity. Well, there are two types of relationships that you need to remember after this lesson. The first one is called directly proportional and the other one is called inversely proportional. I will go through both of them and I will explain what it actually is, how you can recognize it, what are the properties for it, how can you see if quantities are direct proportional or inverse proportional if you look at a graph or at a table. So everything will be clear after this lesson. Let's start with a pretty easy example. Some of you already have a little job. And you all know that the more you work, the more time you spend on your work, the more money you will get. So there is a direct relationship between the amount of time that you're actually working and the amount of money that you get. So, more hours worked, more earnings. You all get that. Of course, the amount of earnings is dependent on the hourly wage. If your hourly wage is of course higher, then you will get more earnings. So, the hourly wage is a constant value. You're going to talk with your boss about your hourly wage, and that's a fixed value. It's not going to change. It's a constant value. Well, if this is a constant value, there should be some kind of relationship between this quantity and this quantity. Well, in this case, we say that the earnings is directly proportional to the hours that you worked. Yeah, so there's a direct relationship. If I double the hours that I work, I will get twice as much money on my bank account. That's the idea. So we call that directly proportional. If you want to write that down in a formula, this is the standard setup for a formula like this. Well, I have different quantities over here, and the first one that you need to notice is the little k. The k stands for constant. It's a constant value. It's not going to change. It can be every value. It can be 1, it can be a million, it can be minus 12. It doesn't matter. It needs to be a constant value. Well, if this is a constant value, then there is a relationship between those two other quantities. And from now on, we're going to call that relationship directly proportional. So, quantity y is directly proportional to quantity x. That's the first one that you need to remember. Well, the second one that you need to remember is inversely proportional. Well, with directly proportional, we already knew if I double one quantity, the other one gets doubled. Well, with inversely proportional, it works slightly different. This is the example. I'm driving in a car with a certain speed, with a certain velocity, and I want to travel a distance, a fixed value, for instance, 5 kilometers. Well, it will take me a certain amount of time to travel that 5 kilometers. You all know that if I speed up, the time will be less. If I slow down, the time will increase. So there's a relationship between the speed of the car and the time that it took me. So, higher speed, less time. So in the previous one you saw if this one increases as well. With inversely proportional, that's not the case. If this one increases, the other one decreases. So, this is the formula, and let's take a good look at the formula. First thing that you always need to do is search for a constant value. Well, the constant value in my example was of course the distance. So the distance is my constant value. That means there needs to be a relationship between the other two. The speed equals the distance divided by the time. So if the distance is a constant value, the other two have a certain relationship, and in this case it's inversely proportional. Well, let's combine that in a general formula. This is a general formula for inversely proportional quantity. So, first thing that you need to notice is that there is a constant value, that is that lowercase k. Again, that can be every value. Doesn't matter if a minus sign or a plus sign, it can be every value. And then the other two need to have a certain relationship, and if you see there is a dividing sign, well, then this is the case. Quantity y is inversely proportional to quantity x. Okay, well, in physics, we always study the relationship between different quantities. That's the main thing that we always do. So here I wrote down 3 different formulas. The formula to calculate the velocity of something, the weight of something, and here the surface area of, for instance, a rectangle. Well, the first thing that you always need to do is search for the constant value. That's an important step. So the constant value in these formulas is this. The distance is going to be a constant value in the first one. In the second one, well, it's of course the gravitational field strength. It's a fixed value, 9.81 here on Earth. And for instance, I'm going to keep the length of that rectangle the same. Well, then you need to figure out what is the relationship between the other quantities. So what is the relationship between the velocity and the time, the weight and the mass, and the surface area and the width. So that is the thing that we study with physics. We're always searching for the different relationships. Okay, so what are the properties of the 2 relationships that we know? Directly proportional and inversely proportional. First thing that you always need to do is, most of the times you are working with a formula. Well, this could be some kind of a formula that you're using. This is the formula to calculate the distance. The distance is the speed or the velocity multiplied by the time. Well, important, first thing, where is the constant value? Let's say in this case I'm traveling with a constant speed. I'm not going to speed up or slow down, so it's going to be a constant speed. So in this case, there should be a relationship between the distance that I traveled and the time that it took me. Well, because there is a multiplying sign over here, you already probably know that they are direct proportional. So if I make t twice as big, well, of course, with a constant speed, I'm traveling twice as far. So that's a relationship we call directly proportional. If I make one twice as big, the other one gets twice as big. Well, with inversely proportional, it works slightly different. Again, that is the formula to calculate the speed or the velocity of something. You take the distance and you divide it by the time. Well, let's keep the distance that you want to travel the same. It's going to be a fixed value. Well, then there is a relationship between the other 2. Well, let's see what happens if I double the time and I travel the same distance. Well, if I double the time, I can drive with twice as less speed. So, in this case, if I double the time, the velocity will be divided by 2. Okay, inversely proportional, directly proportional. Next step. A lot of times you're doing an experiment, and in the experiment you're always creating a table. Well, if you take a good look at your table, you can already see if quantities are direct proportional or not. So here I created a table for 2 quantities, x and y. It could be everything. And what you need to do is you just need to take a look at the values. For instance, this one. If you go from 1 to 3, you all know that my value is actually multiplied by 3. So the x value is multiplied by 3, so I should do exactly the same with the y value if the 2 quantities are direct proportional. Well, take a good look. If I multiply 5 with 3, I get 15. So in this case, those are direct proportional. If you take another value, for instance, from 1 up to 7, it's going to be 7 times bigger. Take a good look at y. What should happen with y? It gets 7 times bigger as well. This table is a good example of 2 quantities that are direct proportional to each other. Well, now let's take a look at the other table. This is the table for inversely proportional. In this case, if you look at a certain value, let's take 1 again, because that's pretty easy. If you multiply it by 4, you get, of course, 4. So the x value is 4. Let's see what happens with the y value. If I multiply this by 4, I should get 20. So it's not directly proportional, but take a good look. If I divide 5 by 4, I get 1.25. And that means they are inversely proportional. If you make this one 4 times as big, this one becomes 4 times smaller. Let's take another value. From 1 up to 8, it gets 8 times bigger, and you see from 5 to 0.63, it gets 8 times smaller. Inversely proportional, directly proportional. Okay, we also create graphs, of course, with physics. So you take all the values of the table, you insert it in a graph, you put quantity y on the vertical axis, quantity x on the horizontal axis, and with directly proportional quantities, you always get a straight line running to 0. So if your graph, your trend line shows you a line that runs through 0 and it's a straight line, you can immediately say that quantity x has a direct proportional relationship to quantity y. Let's see what happens with inversely proportional. With inversely proportional, you always get a graph that looks a bit like this. It's a curved line going downwards, and it tells you that the quantity x is inversely proportional to quantity y. So in a test, if I show you two graphs, for instance those two graphs, you immediately need to know, well, this is a straight line running to 0, direct proportional. This is a curved line, so it tells me it's inversely proportional. Well, here's another example of a formula that we have used in the previous chapter. This is the formula to calculate the weight. The weight was the gravitational field strength multiplied by the mass. Well, first thing that you always do, figure out what is the constant value. In this case, it's at 9.81, it's the gravitational field strength. Well, then the other two need to have a certain relationship. You see there's a multiplying sign over there, so it tells you that those two have a certain relationship, and that is called directly proportional. So the weight is directly proportional to the mass. This is the symbol that we use a lot for direct proportional because it's a pretty long word to write down every time. It's like a small fish. Okay, here's an assignment that I want you to do. There is a table given with a few values, and the thing that I want you to do is complete the table, and after that I want you to draw a graph, the weight versus the mass. Remember, what kind of relationship do the weight and the mass have, and always figure out what is the constant value. So put the movie on pause for a minute, and then I will come back. Okay, so let's complete the table. There's a formula given. The mass is 0. Well, what is the weight in that case? Well, the weight in that case is of course also 0, and 0 divided by 0 won't give you any outcome, so you need to write it down like this. Well, in the next question, the weight is given 300 and the gravitational field strength is given 10, so you just fill it in and you will get a mass of 30. Well, fill in the table for all the other values as well, and you see at a certain moment that the gravitational field strength in this case is 10. I rounded off that 9.81, so it's 10, and it tells you that G is a constant value. It's not going to change. So if you know that G is a constant value and you see there's a multiplying sign over here, you can immediately start drawing a graph, and the graph will always look like this. You will get a straight line running to 0. So make sure you insert the dots correctly, put the quantity and the unit on both axes, and then draw a trend line, and you should score maximum amount of points. So hopefully this was all clear for you, what kind of relationships you could expect during the second and the third year. We always focus on directly proportional and inversely proportional. Thank you for watching. If you liked the movie, put a thumb up, and of course subscribe to my channel. Thanks for watching.